Okay, so let's look at the next part. Number 1, write a function called cm tall, centimeters tall, which takes two parameters, feet and inches, which are both integers that represent a person's height. Okay, the function should return the number of centimeters tall that the person, this is supposed to say is, the person is. Use the fact that 1 inch is 2.54 centimeters. For example, centimeters tall 5'4" should return 162.56. Okay, so this would be a person who's 5 feet 4 inches tall, and then we convert that to centimeters here. All right, so since we're going to write a function, we'll start off with the function definition, def cm tall, and the parameters are called feet, inches. Okay, and then we need a colon at the end of the line. Everything under this will be indented inside of the function. And then at the bottom in the main code, I'm going to put a call to cm tall with 5'4" and make sure that it returns 162.56. Okay, check that this returns 162.56. Okay, so what I need to do here is I only have the information about converting inches to centimeters. So first I'm going to convert the feet and inches into the total number of inches tall that the person is. Okay, so get total inches tall and then convert inches to centimeters. Okay, so you guys know that 1 foot is 12 inches. So maybe I'll call this, I don't know, total, I guess. So we're going to have 12 inches for every foot, and then we're going to have also however many inches were in the in variable. It just occurred to me, actually I'm not sure I'm allowed to use in as a variable, because isn't that the operator in, like when you check if something is in something else? Hold on. Yeah, I think I'm actually not allowed to use that. Oops. We should call it something else, like inches. Okay, so we'll call that inches instead. As soon as I saw it being highlighted in blue, I was like, oh, we can't use that. Yeah, okay, so we don't get an error anymore. All right, and then I need to convert that total number of inches to centimeters. So I'll call this, I don't know, centimeters. And I get 2.54 centimeters for every inch. And then I'm going to return the number of centimeters. So let's see if this works. Yeah, 162.56. Okay. You can do this in a shorter way. Like you could just return, I mean, you could just do it all on one return line like this. Return 2.54 times 12 times feet plus inches or something like that would also work. But I just did it in a few different steps to kind of model the way most people would probably approach it. All right, so let's look at the next one. So the list inventory in the code block below, so this list right here, represents an inventory in a role-playing game. Each entry in inventory is a sublist with 3 entries. So these are the sublists. The first one is here, the second one is here, and so on. The first entry in each sublist is the name of an item, the second entry is the value of the item in gold, and the third entry is the number of that item that the player has. For example, the sublist potion 35 means the player has 5 potions that are worth 30 gold each. Okay, so they've got 5 potions worth 30 gold, they've got 1 sword worth 100 gold, 50 arrows worth 1 gold, etc. Write a program that calculates the total amount of gold that the player's inventory is worth, and the hint here is that the correct answer is 640. Okay, so we're going to need to use the accumulator pattern to get a total. So I'm going to start off my total at 0, and then I'm going to want to loop through the inventory. So I'm going to do for sublist in inventory. Okay, so that's going to let sublist take on each of these sublists here, one by one. And then what do I want to do? I want to add on to the total. So total equals total plus. And then I'm going to need to get the index 1 entry and the index 2 entry from each sublist and multiply them together. Because this is like 5 potions worth 30 each, so 150 gold total, for example. And I think this should do it. Let me try printing this out. Let's see what we get. Yep. So we didn't need to convert these to integers or anything because they already were. All right, let's look at the next one. Okay, so the next problem says write a function called 24 to 12 that takes one parameter, a string called s. The string s will be a time in 24-hour format where AM times are 00, midnight through 11:59, which is 1 minute before noon, and PM times are 12 o'clock noon to 23:59, which is 1 minute before midnight. Okay, hopefully you guys already know how 24-hour time works. The function is going to return a string representing the time in 12-hour format, ending with AM or PM. So for example, if we put in 23:30 for the string, it should return 11:30 PM. And if we put in 9:45, it should return 9:45 AM. Okay, so there are a few things that we need to do here. This is a little bit complicated. So the first thing is, of course, we have to define the function. So 24 to 12 s. And then I'm going to put a couple of test cases down here at the bottom. So if I do 24 to 12 of 23:30, that should return, let me put a print command around it. That should print 11:30 p.m. And if I do a print with 24 to 12, 9:45, that should print 9:45 a.m. Okay, and then within my function itself, there's a few things I need to do. So when I get these times, I need to distinguish between whether they are AM times or PM times. And I can't do that unless I can access this first number that's before the colon and turn it into an actual number and then see whether it is less than 12 or not. Okay. So I'm going to need to use the split command to split apart those two numbers that are in the times. Okay. So I'm going to call this times, and it's going to be s.split, and I'm going to be splitting at the colon. Okay, and then I'm going to take the two times that are in that list that I'm going to get back. It's going to be a list of two strings. For example, if s was 23:30, it'll be a list with 23 as a string for the first entry and then 30 as a string for the second entry. Okay, and I'm going to assign those to be hour and minute, two different variables. So this will be the 0 index entry and the 1 index entry. Oops. All right, and then I also want to convert those to integers so that I can work with them as numbers. Okay. All right, and then a couple of things I need to do. So if the hours are from 0 to 11, that's going to be an AM time. All right, so if hour less than or equal to 11, then all I really need to do is just take the original string, like 9:45 or whatever, and just tack AM onto the end of it. So I'm going to do that. So return s plus AM. All right, let me go ahead and run this and I'll show you. Oh, am I not allowed to start a function with the 24? Oopsie. Let's rename this function something else, like convert maybe. I forgot I wasn't allowed to do that. All right, let's try that again. Oh wait, what am I doing wrong? Oh, it's this one now. Okay, I need to change these two. Okay, there we go. So like the first one's not returning anything because we didn't program how to do this one yet, but for 9:45 it is already doing 9:45 a.m., which is good. All right, and then the next thing I need to think about is for 24-hour times, when they're more than 12, you have to actually subtract 12 from it. But if the hours is 12, I don't have to subtract 12. I just need to put PM on the end instead of AM. So I'm going to do an elif here. If the hour is exactly 12, actually just need to return that the same way that it came in, but with PM on the end. So let me put another test case here just to show you guys. Like if somebody puts in 12:30, it should print 12:30 p.m. Right, so that one is working. And then the last case is if the hour was 13 or more, I need to subtract 12 from the hour. And then I'm going to return, so now I have to build up the string from scratch and not just tacking on AM or PM. So this is a little bit more complicated. So I'm going to need the hour value that I just used, but I need to convert it to a string. Okay, so this is how you convert it to a string. And then I'm going to tack a colon onto the end of that. And then I'm going to tack on the string version of the minutes. And then I'm going to tack on PM at the end. And that should be it. So yeah, you see here I'm getting 11:30 p.m. instead of 23:30. So that is working. All right, so that's it for that one. The next one. A certain store is open from 8:30 a.m. to 5:30 p.m. on Mondays through Fridays, and from 10:30 a.m. to 8:30 p.m. on Saturdays and Sundays. Write a function is open that takes 4 parameters, hour, minute, AM, PM, and day. Okay, so I'm going to start off with def is open, hour, min, AM, PM, day. Okay, so the parameters hour and min are integers representing the current time in 12-hour format. So just like on the last problem. AM, PM is a string that is either AM or PM, and then day is a string that is one of these: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday, and the 3-letter abbreviations. The function should return true if the store is open at that time on that day, and false if the store is closed. So for example, is open 8:30 a.m. Tuesday should return true, but is open 8:30 a.m. Sunday should be false. Okay, so we need a colon here. I'm going to put some test cases at the bottom again, like I've done before. So if I have 8:30 a.m. Tuesday, that should be true. Let me put a print command around this. Print. And if I do print is open 8:30 a.m. on a Sunday, that should be false. Okay. All right, so what do I need to do here? So I think the first thing I have to do to tell whether the store is open or not is to know which day of the week I'm looking at. Otherwise, I can't compare it to the hours that I have. So I'm going to have an if day equal, actually, there's an easier way to do this. So if day in, and then I'll make a list of the ones that are okay. So I'll check if it's the weekend first. And if it's not, then I'll do the weekday hours. So if it's Saturday or Sunday, I need to check if it's between 10:30 a.m. and 8:30 p.m. So it's no good to just check the hour or the minute, because I need to know first whether it's AM or PM. Then I can know what hour or minute I need to look at. Okay. So now I'm going to check if AM, PM equal, I'll just do AM first. Okay. So what are the hours during the AM that the store could be open? If it's 11, if the hour is 11, then it's definitely open. So let's see, if hour is 11, I'm going to go ahead and return true. Otherwise, it's a little bit trickier now. So otherwise, so elif, if the hour is 10, then I need to check if the minutes are 30 or more. So I'm going to do elif hour is 10 and min greater than or equal to 30. Then I'm going to return true in that case as well. And then otherwise I'm going to return false. Oops, these indents they don't correct themselves automatically like they do on some programs. Okay, so the times during the AM when I'll return true on a weekend are if the hour is 11, or if the hour is 10 and minutes is greater than or equal to 30. Otherwise, I'm going to return false for being closed. So that's just for AM. Now back to PM. So if I'm Saturday or Sunday and it's during the PM, then I need to check if the hour is 12, then it's open, or if the hour is less than or equal to 7, then it's definitely open. Maybe, I guess I could just do this all in like one big long, or so the third case when it would be open is, I'm going to put this in parentheses. So the hour is 8 and the minutes are before less than, or I guess just less than 30, since right at 8:30, or yeah, right at 8:30 it will close. So the times during PM when the store is open on weekends is if the hour is 12, so like right after noon, if the hour is less than or equal to 7, or if the hour is 8 and the minutes are less than 30. So we'll return true in that case, otherwise we would return false. Okay, so I just did the weekend. Now I gotta do weekdays too, because this is a pretty complicated program. I could have done this one the same way I did down there, like putting an or here, like if the hour is 11, or maybe that would make it a little bit simpler, but only a little bit. Okay, so now if it's not the weekend, so I'm doing the else from the if all the way up here. So if it's not the weekend, then I'm going from 8:30 to 5:30. Okay, so if the hour is greater than or equal to 9, oh no, I have to check about AM PM first, sorry. So if AM PM is AM, then I need to check if the hour is greater than or equal to 9, or the hour is 8 and the minutes is greater than or equal to 30. Okay, then the store will be open. So I'll return true. Otherwise, I'm going to return false. Okay, so that's AM on weekdays. And now for PM on weekdays. So we close at 5:30. Oops. Okay, so the times in the PM when it's open are if the hour is 12, so between noon and 1 o'clock, or if the hour is less than or equal to 4, or if the hour is, put this part in parentheses, if the hour is 5 and the minutes are less than 30. Then it's open, otherwise closed. Okay, so pretty complicated program actually. There is one way to make it like slightly shorter, which is that you could take this part if here, where when this is true, you're returning true, and otherwise you're returning false. And you could just return that itself, since it will be evaluated as either true or false. When it's true, it'll return true, and when it's false, it'll return false. So that's a way to make it like slightly shorter, but it's still not going to be that short because it's just kind of a complicated program, you know? So I could do it like this. All right. Actually, now that I'm thinking about it, I mean, I guess I could like smush this all into like one incredibly huge long statement with all kinds of ors and ands into it, but I think that would be overly confusing. So, all right, let's make sure that's working at least on these two test cases. Yeah. Okay. So then, if it's Tuesday and it's 8:30 p.m., it should be closed. Yeah. So no, that's false. If it's 8:29 p.m. No, sorry. If it's 5:29 p.m. it should be open, and then at 5:30 it should be closed. Yeah, there's a lot more tests that I could do, but anyway, I'll stop there. Okay, number 5, the list pay in the code block below. Oh no, I forgot to put in the pay list. Derp. I'll have to fix this in a bit. The list pay in the code block below is a list of lists. So I meant to have like a list of lists where it would be like this, and then we would have like some other people, you know, like in addition to Sandra, we could have like Tony. Maybe Tony makes $150,000 and gets a 3.75% bonus. Anyway, I'll do this later. So each sublist represents one employee, that employee's annual salary, and the percentage of that employee's salary that the employee will receive for their Christmas bonus. So for example, the sublist Sandra, $120,000, 4.5 means that Sandra makes $120,000 a year and will get 4.5% of that, which is $5,400 for her Christmas bonus. So the goal is to write a program that will print out a message to each employee telling them what their bonus is. So for example, example, Sandra's message should be, Dear Sandra, your Christmas bonus is 5,400. And you're going to print out the message for all the employees. So let me put a few more employees in here for us to work with. Okay, so I just put a few more people in here. And now let's go ahead and try doing this part. So we are going to do a for loop through this list of sublists. So we're going to do for sublist in pay. Okay, and then we're going to go through each entry in pay one by one and print out the message. So I'm going to call message, I'm going to start it off as like dear and then plus the name of the person. Okay, so to get their name, we're going to do sublist index 0. So if I just do this much and print it out, we should be able to see the program kind of coming together already. So I've got everybody's names. Oh, I need a space here. Okay, so I've got all their names coming out already. And then I just need to keep going with that. So next I need to tack on, so I'm going to use plus for concatenation, comma, space, your Christmas bonus is space. All right, so I've got most of it now. And now I just need the part where I do the calculation. So let me do that here. So bonus equals, so what I need to do is grab their salary, which is going to be sublist index 1, multiply it by their percentage, which is sublist index 2. All right, and then actually need to divide that by 100 because this is a percentage. Okay, and then I'm going to add that onto the end of message. So I'm going to do message equals message plus. And I'm going to need to convert it to a string. So this is going to be string. Oh, I should probably put a $sign right here too. Right there. All right, so I'm going to convert bonus to a string. And then that should be it. Yep. I guess I could convert these back to integers maybe. But I don't know if they will always come out as integers, so we did learn some tools at some point in the class on like how to get a certain number of decimal places, but I think I'm just not gonna worry about that. Oh, I was supposed to have a period too. I don't know. Do people round off Christmas bonuses? I don't know. Maybe it would look nicer if I rounded it off. Let's try it. So if I convert that to an integer, and then I'm going to tack like a period onto the end, will this look nicer? Yeah, I guess technically that is how I asked for it to look up here. Okay. So that is that one. Now for the last one, number 6, write a function called sarcastic that takes one parameter, a string called s. The function should return the same string, but with alternating lower and uppercase characters. So for example, sarcastic of Susquehanna would return this. So lowercase s, uppercase u, lowercase s, uppercase q. So it's kind of like how people write sarcasm on the internet sometimes. Oh, there are more after this. I'm sorry. I was thinking there were only 6. There's 10. Okay, we'll be here a while longer. Right, so we're writing a function with parameter s. It's going to look like this. And I'm going to use the accumulator pattern. So I'm going to start off with another string called t that's going to start off empty. And then I'm going to build up t letter by letter. So I'm going to loop through the letters in s. And I'm going to add them one by one to t. If the letter is like index 0, 1, or sorry, index 0, 2, 4, 6, 8, etc., then I'm going to add the lowercase version. If the index is 1, 3, 5, 7, etc., then I'm going to add the uppercase version. So I guess actually what I want to do is not loop through the letters. I want to loop through numbers. So like for I in range, len s. So this will go through the numbers of the indexes that would index into s. Okay. That way I can check whether it was an even or an odd index. So if the index is even, I want to put the lowercase version into t, and if the index is odd, I want to put the uppercase version into t. So I'm going to check if I%2 is 0, then I'm going to do t equals t plus, and I'm going to do, so now I'm trying to add on the letter to the end of t. So to get the letter with the index I from s, I just do it like this, s bracket I, and then I'm going to do dot lower, like that. Okay, and then otherwise, if the index was not even, then it must have been odd. So for down here, I'll do t equals t plus s bracket I dot upper. Okay, and then we're going to return T at the end. So let's do some test cases. Print sarcastic Susquehanna. Yep, there we go. Here's my name. Yep, still working. Okay, so that is how that works. All right, so number 7, write a function called countUniqueChars that takes one argument, a string called s, and returns the number of unique characters in the string. For example, in the string Susquehanna, the unique characters are capital S, lowercase u, s, q, e, so we already had one u, so the second u is not unique, h, a, n, and that's it. So those are all of the unique characters in the string, and there's only 8 of them, so the function would return 8. Okay, so let's go ahead and define the function. So def count unique chars s. Okay, so we're going to need to use the accumulator pattern since we're counting things. So I'm just going to start off with count equals 1. Or sorry, 0. That's where counts start, right? I think I'm getting tired. So the count starts off at 0, and then I'm going to need to go through the characters in the string one by one. So like this, for char and s. And now I need some way of checking whether the character is unique or not. So like, in other words, whether I've seen it before. So maybe what I want to do is not only accumulate a count of how many unique characters there are, but also accumulate the list of the unique characters. And that way I can just check if things are in that list or not. Or I could do it as a list, or I could also do it as a string. Maybe I'll do it as a string. So I'll call this uniques, and I'll start it off as an empty string. Okay, so before I've looked at any characters, I haven't seen any yet, and I've seen 0. Okay, so then for each character in the string s, I want to check if that character is already in the unique string, or rather whether it's not in there. So if the character is not in the uniques string, then I've found a new unique character, right? So I would want to increase my count by 1, and I would also want to add that to the end of the unique string. Okay. So then at the end, I just need to return the count. And I think that's pretty much it. So let's go ahead and test it. So print count unique chars. Susquehanna, make sure that's 8. Okay, let's try another string. Let's do my name. Let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. That should be 8 as well. Oh, 10? Do I have 10 unique characters? Okay, let me try again. 1, 2, 3, 4, 5, 6. Oh, there's 6 in the front, right, because of the capitalization. Okay, so 6. Oh, and then the space, so that's 7. Okay, and then 8 is the J, 9 is N, 10 is S. Okay, that makes sense. All right, so we'll leave that one like that. Looks like it's working. Okay, number 8, the list. Oh, good, I made the actual gradebook. The list gradebook in the code block below represents the end of semester grades at a certain school. Each sublist is one student and the grades they got in the 5 classes they took that semester. The GPA for an A is 4.0, for a B is 3.0, for a C is 2.0, for a D is 1.0, and for an F is 0.0. This is true, actually. That is how the GPAs work. Students whose semester GPA is 3.0 or above are on the honor roll and will receive a reward. Make a list of the names of the students who are on the honor roll. Okay, so basically we have to calculate the average GPA. Well, it sounds silly if I call it average GPA because it stands for grade point average already. So the average, grade point average. So if the average GPA for a student is 3.0 or above, then we put their name on the honor roll. So this is a little bit tricky. And there are a few ways to do it. I think one way to do it that would be efficient would be with a dictionary, but you guys might have forgotten all about dictionaries. I don't know. But I'm going to do it with a dictionary. So basically, I want to have a GPA dictionary. So I'll call it GPA dict. And then I want to have an A be a 4.0, a B is going to be a 3.0, a C is going to be a 2.0. So the other way you could do this would be with just a bunch of conditional statements. I think that would be pretty long piece of code that you'd have to write to do it that way. And then an F is a 0.0. I guess I could have just done these as integers like this, couldn't I? They didn't really need to be floats. Well, anyway. Okay, so now what I'm going to do is I'm going to make a list called honor roll, and I'm going to start it off as an empty list, and then I'm going to use, I'm going to use the accumulator pattern to add names to that honor roll list whenever I find someone who should be on it. So now I'm going to go through the sublists in the grade book. So each sublist represents one student. The first sublist will be this one, Alana CABCB. And I'm actually going to have to use another instance of accumulator pattern here to come up with the total so that I can get her average. So I'm going to add up the points for each of her grades and then divide them by 5. So her total is going to start off at 0. And then what I'm going to do is, let's see, so I'm going to do for grade in, so I don't want to do for grade in sublist because then that's going to treat Alana's name like she's a grade. I guess I'm going to have to do the slice from index 1 to the end of that sublist, like that. So then sublist 1 colon, this is a slice starting at index 1 going to the end of the sublist. So it'll be just these 5 grades right here. So I'm going to go through those and I'm going to add the grade points to the total. So total is going to become total plus, now I'm going to need my GPA dictionary. So I'm going to go into GPA dictionary, and then I'm going to index the grade. Okay, and then it's going to return me the number that is associated with that grade. Okay, once I've looked through all of her grades, then I'm going to divide the total to get the average. So her GPA is going to be total divided by 5 because it's 5 classes. And then what I'm going to do is if her GPA is greater than or equal to 3, I'm going to add her name to the honor roll. So I'm going to do honor roll dot append, and I have to be careful here to get the entry that's her name. So I'm in the sublist and her name is index 0 in the sublist. So it's like this. And let me print out the honor roll at the end. Let's see what it is. I should have put a like a hint here about what names actually belonged on it. I might have to like check a few of these by hand to make sure. But if I look at Alana, for example, so basically if you have a C and an A, those are going to, so C is 2 and an A is 4, which is 6 together. So a C and an A is 6, which is exactly the same as a B and a B. So if you have a C and an A, they kind of like counteract each other and they act like you have 2 Bs. So this would be like having a B, a B, a B, a B, and then this C. So she should be below 3.0. That's not honor roll. Let me see. Benji here. So this would be like B. This is basically 2 Bs, a B and a C. So he shouldn't be on it. Yeah, Kate should be on it. She has all A's. Let's see. Devin. Whoa, no way is Devin on it. Let's see. Ethan. So this A and this C would act like 2 Bs, and then, yeah, so it would be like B, 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 and then an A. So yeah, he should be on it. Flora, yeah, she should definitely be on it. All A's and Bs. Gavin is a little hard to tell. Hector, yeah, some of these are more harder to tell whether it's actually right or not. Maybe what I want to do is like print out what their GPAs are, so I see if I'm getting like normal numbers or if any of them look crazy. 4.0, 1.6. Yeah, okay. I don't know. There's not really a good way to check this other than getting out a calculator and converting these all by hand. I think I'll just assume this is correct for now. All right, so number 9. Write a function called MDY that takes one argument, a string S, which is a date in the format YYYYMMMDD, such as 2023-09-01. And the function should return another string, which is the date in the format MMMDYYYY, such as September 1, 2023. Okay, so this is a little bit tricky, and I think we are going to need either either a dictionary or a list to convert these numerical months to these verbal months. So I'm going to start off by writing that month dictionary. Okay, so if the number is 1, I want it to be January. If it's 2, I want it to be February. 3 should be March. 4 should be April. 5 is May. Oh, these need to be strings. Gosh. Oops. So they're going to have quotes around them. Okay, 6 is going to be June. 7 is going to be July. 8 is going to be, August. 9 is going to be September. Remember, everybody, I promised you on the first day of class that programming is not exciting. So you can't complain. 11 is going to be November. And 12 is going to be December. December. Oh, in quotes. Okay, so I'll need that later on. And now let me think about what else do I need. So I'm getting a string where the 3 parts are separated by hyphens. So I think I'm going to need to use dot split to get that apart. But let me go ahead and define the function up here at the top. So it's called MDY. And it takes a string S. Okay, so I'll do this month dictionary thing inside of there. All right, so I'm going to need, I don't know what to call it, like L maybe. I'm going to take the string S and I'm going to split it at hyphens like this. And so the 0 index is going to be the year. So I'm going to call that year. The month is going to be the 1 index, so L1. And then the day is going to be the index number 2. And I'm going to convert all of these to integers so that I can work with them as numbers. I guess I don't really need to do that, but one thing I noticed was here I'm going to have like 09 and 01, but I don't want to have those zeros over here on September 1. So then I need to convert them to integers so that the zeros will be taken away. All right. Okay, so this will be the year, the month, and the day. And let me create a new string called answer. So I'll start it off as a blank string, and then I'll add each thing to it that I need. So it's going to be first the month. So I can get that from my dictionary. So it's going to be month dict index, and I'm going to index to the month. So this number right here is what I'm going to plug into the dictionary. So for example, if the number was 9, then Python's going to look up this 9 here, and it's going to return me the September part. Okay, so that's the first thing. Then I'll use plus for concatenation. I'm going to want a space. So right here, there's a space. And then I'm going to want the day. And I'm going to need to convert this to a string, because you cannot concatenate a string to anything but a string. So this will be string day. Okay, and then I'm going to want a comma and another space. So comma, space. And then the last thing is going to be the year. I guess I really don't need to convert the year to an integer, but whatever, I already did it. So I'll convert it back to a string here. All right, and then I'm going to return this answer. And let's go ahead and test this down here. So print MDY. So I'm going to put in 2023-09-01. Yep, it's working. Let's try some other ones. Maybe, what's today? December 10th. So 12/10. Yep, December 10th. Yeah, seems to be working. All right, so now the very last one. Write a function called vector add, which takes 2 lists, v and w, as parameters. So I can go ahead and start vector add VW, colon. Okay. The 2 lists will each have 3 numerical entries representing the XYZ components of 2 3-dimensional vectors. You don't really have to know what that is, but the important part is the function should add the 2 vectors and return a list of 3 numbers for the result. So for example, vector add 1, 2, 3, 4, 5, 6 should return 5, 7, 9. So what's happening here is you're adding each pair of entries, one from each list. So you're adding the 0 index entries together. That's giving you 5. you're adding the 1 index entries together, so 2 and 5 is giving you 7, and then you're adding the 2 index entries together, 3 and 6 gives you 9. Okay, so I'm going to put this down here as a test case at the bottom. So this is 1, 2, 3, 4, 5, 6. All right. So now up here at the top, so I'm going to create a new list to be the answer, and I'll use the accumulator pattern to build up this list entry by entry. So now I don't think I want to loop through the entries in either of these lists. What I actually want to do is loop through the indexes into these lists so that I can index into both of them. So I'm going to do for I in range len v. Okay. So then I is going to go through all of the possible indexes starting from 0, 1, 2, 3, etc. All the possible indexes into the list V. And then I'm going to append onto the end of the answer list, I'm going to append the current sum of the entries at index I in my 2 lists. So V index I plus W index I is what will get appended to the answer list. And then at the end, I'm just going to return the answer. And that's it. So you see it is working. I could test it with a few more numbers. Let's see what we get. So I should get, let's see, 7 plus 0 is 7, 2 plus 1 is 3, and then 4, so 7, 3, 4. Yep, it's working. Okay, so that is it for this section.